Instead of being with you in Poland, I'm here sending you warm greetings from sunny California. Well, actually, I'm not in California at the moment. I am in the state of Nevada, traveling on a road trip on the historic Route 395 from Reno, Nevada to Southern California, where I live. This road extends nearly 2,100 kilometers or 1,300 miles, starting in the Mojave Desert, which is the driest desert in North America, all the way to the Canadian border in Washington State. I'm going to be showing you some spectacular scenery of peaks, of lakes, also of some dormant or sleeping volcanoes. I'm not a geologist, but luckily I have a geologist with me, my husband, Mike Huggins, who is helping me explain to you some of the geologic features we'll be seeing. Hi again. We're currently at Mono Lake. Mono Lake has a lot of salt in it. In fact, so much salt, it is 3 times as salty as an ocean. And because of the high level of salt, its pH is very high, which makes it highly alkaline. When you combine this with the warmth of the waters, you'll see that there are formations called tufa formations. They're limestone towers that build up in the lake. We're going to go down closer to the lake so you can see these rising above the lake a little bit easier. The color of the lake often depends on the amount of algae and the amount of shrimp in the lake that is eating the algae. Another interesting fact is that Mono Lake is part of a geologically active volcanic chain. The most recent eruption was 350 years ago. The island you see in the middle of the lake is a cinder cone formed by the explosive eruption through a volcanic vent. So we're at Mono Lake again, and as you can see, we are much closer to the tufa formation. You can see them jutting up above the water line. In fact, the water line used to be so high that those tufa, the formations, were totally covered with water. And over time, there's been recession of water exposing these limestone formations. And as an example in front of us, we see more limestone. In fact, the water level used to be this high, and this tufa was covered with water from Mono Lake. Now you can get a closer peek at the black island that was the cinder cone from a volcanic eruption. And next to that island is another island with this whitish color, and that was from a previous volcanic eruption. I'm at the Mono Lake Visitor Center, and in the distance you'll see some gray mounds. Those gray mounds are called mono craters, and the last eruption of those volcanoes was thought to be 650 years ago. If you ever wondered what comes out of a volcano, here's an example. This is a volcanic glass called obsidian, and it's a very large rock. Here's Mike showing us an example of another type of rock that comes out of a volcano. This is called pumice, and as you can see, it's pretty lightweight compared to that piece of obsidian we just looked at. We're in Mammoth Lakes, California, next to Twin Lakes, and there's a magnificent waterfall right above me. It's just lovely. The water is flowing over former volcanic lava flows. The temperature here is at least 25 degrees less than it was previously. It's in the high 50s Fahrenheit and a little bit nippy. Hi, this may look like a peaceful valley, but its origins were, let's say, a blast. You're looking at Long Valley Caldera. A caldera is a collapsed area of land following a super volcanic eruption of magma. This area covers 20 760,000 years ago. The event was so large that volcanic ash was found all over the western part of the United States. The area is also known for its geothermal hot springs. Some of them are cool enough for people to enjoy a warm soak, but others are far too hot and dangerous to go in. Let's have a look at what surrounds Mammoth Lakes, California.
Hi, Dzień dobry. I'm Mike, I'm Barbara's husband, and we've pulled off Route 395 to get a look at some interesting sites here. We're between Mammoth Mountain and Bishop. We're east of the Long Valley Caldera, and we stopped here because this is the front of the Sierra Nevada mountains. And the Sierra Nevada mountains were uplifted along a fault system here, pushed up over the last 90 million years. And then right here, there's a valley which is U-shaped like this, and during the last ice age, more than 10,000 years ago, back to about 1.6 million years, this is a much colder climate. There were glaciers here, and at one time there was a valley glacier sticking out right there. You can see the mounds of dirt. That was the dirt that was pushed out by the glacier out into the edge of the valley. So it would have been much colder during the ice age. There would have been a glacier right there. And again, this is the front of the Sierra Nevada mountains. Hi, we've made another stop between Bishop and Mammoth Mountain, a few miles from our last stop. And behind me is a thick sequence of rock, maybe 20, 30 meters high. All that rock was ejected, blown out of the Long Valley supervolcano eruption 760,000 years ago. It was erupted in a period of hours to days and deposited pretty much all at once. It's 20 to 30 meters high and it's solidified volcanic ash. It's called the Bishop Tuff, and it's widespread over this area between Bishop and Mammoth Mountain, and it all came from that one big eruption.
We're still traveling southbound on the 395, but pulled off the side of the road so you could have a look of what the Sierras look like. The Sierra Nevada mountains are 90 million years old. They were created by the movement of the tectonic plates under North America. In the foreground you see brown-colored mounds, and this is evidence of more recent volcanoes. In fact, there's a clear example of a volcanic crater, and with the black rock, you see a recent lava flow.
Hi, we've made another stop along 395 between the cities of Bishop and Lone Pine on our trip south. And we stopped here because it's a good example of the Sierra mountain front right behind me. You can see the high Sierras, you know, they were created 90 million years ago, but then they were uplifted. And then right behind my back, these big black blocky rocks, those are part of a much younger lava flow that erupted from a volcano probably over there on the other side of the road and near the foot of the mountains. And this kind of volcanic lava is very similar to what they have in Hawaii. And the Hawaiians call this kind of lava a'a lava.
We've stopped in a small town called Lone Pine. Lone Pine became dramatically transformed in the 1920s because of the movie industry. In fact, over 400 movies have been filmed here and over 100 television shows. Largely, that was because of these incredible hills around us. We are standing in the Alabama Hills. The Alabama Hills consist of granite, which is a very hard rock. Off in the distance, you see the high peaks of the Sierras. Now, there are many peaks that are well over 10,000 feet high in the Sierras, but we're looking at the tallest, Mount Whitney. It is 14,505 feet high, or 4,421 meters. Now, we're not going to be hiking up Mount Whitney today. There's been recent earthquake activity, and that road has been closed because it's no longer safe.
Hi, we're at Fossil Falls, our final stop on our little geology road trip of 395 from Reno, Nevada down to Southern California. And we're standing out in a field of lava. These black lava rocks here were formed in lava flows that came from this small volcano back here, which erupted last about 30,000 years ago. And the reason we're here, and we're going to walk over to it, we'll take a video of that place, is there's a fossil waterfalls, meaning there used to be a waterfalls here, and there's a little canyon cut, and the canyon was cut by Ice Age rivers. During the Ice Age, 10,000 more years ago, there was ice all over the southern Sierras over here, and great big lakes in the big valley here. The water flowed through here quite rapidly, and they downcut some waterfalls. Well, those lakes and the ice are all gone, and the old waterfalls, high and dry, is still here. We're going to go over and take a look at it because there's some interesting features over there. Hi, we're now at the Fossil Falls. This is the ancient riverbed, the ancient waterfalls that were here. It was cut by the ancient Ice Age river that flowed through this riverbed. Southern Sierras are on our background. If you look around, you can see these potholes that were cut into the rock, the volcanic rock here, by boulders and rocks swirling around in the water current.
We would like to thank you for joining us on this geology road trip. It has truly been our pleasure to share this information with you about the little known spots along the 395 and what the significance is. Also, we hope someday to meet you. We just would like to say,
Do
widzenia. Thank you.